The hydraulic arms of the CAT 390F excavator penetrate the surface of the Nevada desert with mechanical precision, breaking through layers of compacted sand that haven't been disturbed since 1964. Sound of diesel engine idling at low RPM. The operator, a civilian contractor named Marcus Webb with 17 years of experience in hazardous material remediation, adjusts the pressure on the joystick controls as the reinforced steel bucket cuts through what the Pentagon classified as Zone 7 Charlie, a contaminated perimeter on the northern edge of Groom Lake, where experimental rocket propellants were allegedly dumped during the height of the Cold War. The soil here registers 12,000 counts per minute on the Geiger counter mounted to the cab's exterior frame, a reading that necessitates the use of lead-lined protective equipment and respirators with activated carbon filters. Webb has cleared 37 tons of irradiated topsoil in the past 6 days, filling industrial dump trucks that transport the material to a classified disposal facility somewhere beyond the Emigrant Valley. The work is monotonous, methodical, and pays $300 per hour precisely because of the radiation exposure waiver every contractor must sign before stepping onto this particular grid coordinate. But at 11:47 in the morning on a Tuesday in late October, when the ambient temperature has already climbed to 104 degrees Fahrenheit, and the shimmer of heat distortion makes the distant mountain ranges appear to float above the horizon, the bucket of Webb's excavator strikes something that produces a sound entirely different from the usual scrape of metal against rock or the soft compression of contaminated sand. Sound of metal impacting an unknown alloy with a deep resonant tone. The vibration travels up through the hydraulic systems and into the operator's seat, with enough force that Webb immediately releases the controls and kills the engine. The sudden silence is absolute, except for the ticking of the cooling diesel block and the whisper of wind across the flat expanse of the dry lakebed. He climbs down from the cab, his boots crunching on the crystalline surface of the desert floor, and approaches the excavation pit with the portable radiation detector held at arm's length. The needle jumps erratically, but settles back to baseline, indicating that whatever lies beneath the sand is not the source of the ambient radiation. Webb kneels at the edge of the trench and uses a gloved hand to brush away loose sediment from the object that has halted his equipment. What emerges from the dirt is a surface of such unusual composition that his first instinct is to back away, convinced that he has uncovered some piece of exotic ordnance or perhaps a fragment of a crashed satellite. The material is black. Not the matte black of painted steel, but a black that seems to absorb light entirely, creating an optical effect where the edges of the object are difficult to perceive against the surrounding soil. The texture is smooth yet not quite metallic, with a faint pattern of microchannels running across its surface that suggests aerodynamic functionality rather than structural necessity. Webb runs his fingers along what appears to be a leading edge and realizes with a sudden cold clarity that he is touching the wing of an aircraft. 4 seconds of absolute silence. Desert wind sound. The surface area of the exposed section measures approximately 8 feet across, but the angle at which it descends into the earth suggests a much larger structure buried beneath. Webb immediately radios the site supervisor, a former Air Force Master Sergeant named Coleman, who oversees all remediation operations within the restricted airspace of the Nellis Range Complex. Coleman arrives within 12 minutes in a dust-covered Ford F-350, accompanied by 2 security personnel wearing the unmarked black tactical uniforms that indicate direct oversight from the Defense Intelligence Agency. The 4 men stand at the edge of the excavation pit and stare at the wing section in silence, each of them understanding that protocol now requires immediate escalation to authorities far beyond the civilian contracting chain of command. Coleman makes 3 phone calls, and within 90 minutes the site is transformed. A Sikorsky CH-53K King Stallion helicopter delivers a modular containment system, essentially a collapsible clean room with aluminum framing and heavy-gauge polyethylene sheeting that can be erected around the excavation zone to prevent satellite surveillance or reconnaissance overflights from observing the recovery operation. Additional excavators arrive, along with vacuum trucks equipped with industrial suction systems capable of removing soil without the risk of damaging whatever lies beneath. The crew expands to include structural engineers from a private defense contractor based in Palmdale, California, and a team of materials specialists who arrive without identification and speak to no one except Coleman in terse technical exchanges about titanium-aluminum alloys and oxidation resistance. The excavation proceeds with extreme caution, over the next 72 hours. The vacuum system removes soil in controlled layers, while ground-penetrating radar maps the dimensions of the buried object in real time. What the scans reveal is a complete aircraft, approximately 79 feet in length, with a delta wing configuration and a fuselage cross-section that matches no known production model in the historical record of American aviation. The craft is oriented nose down at a 30-degree angle, as if it had been deliberately positioned rather than crashed. There is no impact crater, no debris field, no indication of structural failure or catastrophic event. Instead, the evidence suggests that this aircraft was buried intact, lowered into a pre-excavated trench, and covered with the same contaminated soil that now serves as both concealment and deterrent to unauthorized investigation. Sound of vacuum suction removing fine sediment. The materials team begins extracting samples from the exposed wing surface using diamond-tipped core drills, and the preliminary analysis conducted on-site with a portable X-ray fluorescence spectrometer indicates a composition of titanium 6 aluminum 4 vanadium alloy with trace elements of niobium and molybdenum, a formulation that would not become standard in aerospace manufacturing until the late 1970s, more than a decade after this aircraft was apparently entombed. The implications are immediate and disturbing. Either the dating methodology is flawed, or this aircraft was constructed using materials that were not yet commercially available during the era of its burial. By the 5th day of excavation, enough of the fuselage has been exposed to reveal identifying features that narrow the speculation considerably. The aircraft possesses a chined forebody similar to the Lockheed A-12 reconnaissance platform, but with a more pronounced curvature that suggests optimization for radar cross-section reduction rather than pure aerodynamic efficiency. The engine nacelles are buried too deeply for direct inspection, but the dimensions and spacing indicate a twin-engine configuration, most likely variants of the Pratt & Whitney J58 turbojet that would later power the SR-71 Blackbird. What makes this discovery extraordinary is not merely the sophistication of the airframe, but the context of its burial. Documents declassified under the Freedom of Information Act in 2013 revealed that the Central Intelligence Agency maintained a covert research facility at Groom Lake throughout the 1960s, codenamed Project Idealist, which focused on the development of high-altitude reconnaissance platforms capable of sustained flight above 75,000 feet at speeds exceeding Mach-3. The official narrative states that this research culminated in the A-12 and its successor variants, but the existence of this buried prototype suggests a parallel program, something developed and then deliberately erased from the historical record. Sound of industrial crane hydraulics under strain. The recovery team installs a gantry crane system capable of lifting 80 tons and begins the delicate process of extracting the aircraft from its earthen tomb. Synthetic webbing straps are threaded beneath the fuselage at multiple load points, and the crane applies upward force in increments of 500 pounds, while engineers monitor stress gauges welded to the airframe's structural hardpoints. The aircraft rises from the sand, with a sound like tearing fabric as centuries of compacted sediment releases its grip on the titanium skin. What emerges is not the corroded wreckage one would expect from 6 decades of burial in chemically contaminated soil, but rather a structure in a state of preservation so immaculate that it appears to have been entombed only months prior. The black coating on the exterior surface shows no signs of degradation, no rust bloom, no pitting from electrochemical reactions with groundwater salts. The canopy glass, a curved transparency that extends from the nose to the midpoint of the fuselage, remains intact without so much as a stress fracture. This level of preservation is inconsistent with the known behavior of aircraft materials exposed to environmental factors over extended time periods, and it raises uncomfortable questions about the nature of the coatings and sealants used in the aircraft's construction. Were these materials so advanced that they resist all forms of chemical breakdown, or was the burial environment specifically engineered to prevent deterioration? The second possibility suggests premeditation, a deliberate effort to preserve this aircraft for future recovery, under circumstances that its builders could not have anticipated. 4 seconds of absolute silence. Radio static hum. Once the aircraft is fully suspended above ground level, the recovery team constructs a mobile transport cradle, a steel framework mounted on articulated hydraulic dollies that can distribute the weight across multiple axle points. The aircraft is lowered onto this cradle and secured with titanium bolts torqued to specifications provided by the materials engineers. And the entire assembly is then enclosed within a climate-controlled transport container fabricated from welded aluminum panels with interior insulation rated for temperature stability within 2 degrees Celsius. The purpose of this container is not merely to protect the aircraft during transport, but to prevent any form of remote sensing or visual observation during its movement across the Nevada test and training range. At 0300 hours on the 9th day of the recovery operation, a convoy departs the excavation site consisting of the transport container mounted on a 60-axle modular trailer, pulled by twin Kenworth heavy haulers, flanked by 4 unmarked Chevrolet Suburbans with blackened windows, and preceded by 2 Nevada Highway Patrol cruisers that will block all intersections along the predetermined route. The convoy travels at 19 miles per hour, slow enough to prevent structural stress to the aircraft, but fast enough to reach the destination before sunrise. That destination is a hangar complex on the southern edge of Groom Lake, a facility that does not appear on any satellite imagery available to civilian researchers and is identified on internal Air Force documents only by the designation Building 477. The aircraft remains in climate-controlled storage for 3 weeks, while a team of aviation archaeologists from the Smithsonian National Air and Space Museum is flown to the site under non-disclosure agreements that carry criminal penalties for violation. These specialists are permitted to conduct a complete photographic survey and dimensional analysis, but are prohibited from publishing their findings or discussing their observations with any individual not cleared for access to special access programs at the TSSCI level, with additional compartmentalized clearances. What the Smithsonian team documents is an aircraft that represents a technological leap beyond anything fielded by the United States Air Force or Central Intelligence Agency during the early 1960s. The radar-absorbent coating applied to the exterior surfaces consists of microscopic iron spheres suspended in a polymer matrix, a formulation that would not be independently developed until the Have Blue Stealth Demonstrator program of the late 1970s. The engine intakes incorporate fixed geometry ramps with boundary layer suction, a design feature intended to maintain stable airflow at supersonic speeds without the mechanical complexity of variable geometry systems. Most significantly, the aircraft's ventral surface shows evidence of a recessed weapons bay, suggesting that this was not purely a reconnaissance platform, but rather a strike aircraft capable of delivering ordnance while maintaining a reduced radar signature. The existence of such a capability in 1964 challenges the established timeline of stealth technology development and raises the question of why this aircraft was never operationalized. Sound of metal panel being carefully removed. The answer begins to emerge when technicians gain access to the cockpit interior. The canopy is released using a mechanical override system, a series of titanium pins that must be driven out with hydraulic pressure, because the original pneumatic actuators have seized after decades of inactivity. When the canopy finally separates from the fuselage with a hiss of equalizing pressure, the technicians are confronted with an environment that has remained sealed since the day this aircraft was buried. The air inside the cockpit carries the distinct chemical signature of JP7 jet fuel mixed with the acrid scent of electrical insulation and the sweet metallic odor of hydraulic fluid formulated from phosphate esters. The pilot's seat is a customized ejection system manufactured by Weber Aircraft, the same company that would later supply seats for the SR-71 program, but this particular unit incorporates features not found in production models, including an integrated life support backpack that suggests this aircraft was designed for flight profiles extending beyond the operational ceiling of conventional pressure suits. Mounted to the left side of the instrument panel is a clipboard secured with a spring-loaded clamp, and on this clipboard are 17 pages of typewritten documents bearing classification markings that have never been observed on declassified materials from this era. The header on each page reads Project Isinglass, a program name that does not appear in any public archive or historical account of Cold War aviation development. The documents describe a joint initiative between the Central Intelligence Agency and the Air Force Systems Command to develop a hypersonic reconnaissance platform capable of sustained cruise at Mach 5.6 at altitudes exceeding 120,000 feet. The program was initiated in 1961 in response to Soviet advances in surface-to-air missile technology that threatened to negate the operational effectiveness of the U-2 reconnaissance aircraft. Lockheed's Skunk Works division received a contract to explore several design concepts, including a hydrogen-fueled aircraft designated CL-400 and a liquid methane variant known as CL-480. The documents recovered from the cockpit indicate that the buried aircraft represents a third approach, a testbed designated X-27A that utilized conventional JP-7 fuel but incorporated experimental ramjet technology intended to extend the aircraft's top speed beyond the limitations of turbojet propulsion. According to the typewritten mission profile, the X-27A was scheduled to conduct its first powered flight on December 14, 1964, launched from a B-52 mothership over the Nellis Range Complex. The flight plan called for acceleration to Mach 3.2 at 70,000 feet, followed by a sustained cruise lasting 12 minutes before deceleration and landing at Groom Lake. The documents provide no indication of whether this flight actually occurred, but the presence of the aircraft in a burial trench suggests that something catastrophic happened, either during the flight itself or immediately afterward. 4 seconds of absolute silence, wind over desert hardpan. Further examination of the cockpit reveals anomalies that deepen the mystery rather than resolve it. The primary flight instruments include an inertial navigation system manufactured by Honeywell, but the unit is a variant that would not enter production until 1967, 3 years after the aircraft's presumed burial. The radar warning receiver displays a frequency coverage extending into the X-band and Q-band ranges, an unusual specification given that Soviet air defense radars of the early 1960s operated primarily in the S-band and C-band frequencies. Most disturbing is the presence of a data recorder mounted behind the pilot's seat, a device that resembles a magnetic tape storage system, but utilizes a recording medium that materials analysis identifies as a cobalt-chromium alloy sputtered onto a polyester substrate, a technology that would not become commercially viable until the introduction of digital tape formats in the late 1970s. The implication is that this aircraft incorporated components that should not have existed in 1964, which leads to 2 possible conclusions. Either the dating of the burial is incorrect, or the aircraft was constructed using technologies that were decades ahead of publicly acknowledged capabilities. The intelligence community refers to such discrepancies as temporal paradoxes, situations where physical evidence contradicts established historical timelines, and the standard protocol for resolving these paradoxes is to reclassify the evidence at a higher security level and restrict access to a smaller pool of cleared personnel. The flight data recorder is carefully removed from its mounting bracket and transported to a signals intelligence facility at Fort Meade, Maryland, where specialists in legacy data formats attempt to recover whatever information remains on the magnetic tape. The process requires the fabrication of a custom playback head capable of reading the non-standard track width and encoding scheme used by the recorder. After 6 weeks of engineering work, the team succeeds in extracting approximately 43 minutes of audio recordings and telemetry data. The audio consists primarily of communications between the test pilot and ground control at Groom Lake, along with the pilot's verbal notes regarding aircraft performance and handling characteristics. The pilot's voice is calm and methodical as he describes the acceleration through Mach 2.8, noting that the aircraft exhibits mild pitch instability at transonic speeds, but becomes increasingly stable as velocity increases. At 14 minutes into the recording, the pilot reports visual confirmation of ignition in the ramjet augmentation system, and the telemetry shows a corresponding spike in thrust output and airspeed. The aircraft reaches Mach 3.4 at 76,000 feet, exceeding the planned mission profile by 0.2 of a Mach number, when the pilot's tone changes abruptly. He reports a failure in the number 2 engine hydraulic system, followed almost immediately by a loss of control in the starboard elevon. Ground control instructs him to initiate emergency shutdown of the affected engine and attempt a single-engine return to base. But the pilot's next transmission is cut off mid-sentence by a burst of static that overwhelms the recording equipment. The telemetry indicates a catastrophic electrical failure across all aircraft systems simultaneously, followed by a sudden loss of altitude at a rate exceeding 12,000 feet per minute. The recording ends with the pilot's fragmented transmission. Control, X-27, experiencing total. Cannot maintain. Ground effect negation is Recommend immediate. Sound of audio tape degradation and magnetic dropout. What happened in the seconds following that transmission remains classified. But the existence of the aircraft in an intact state suggests that the pilot managed either to execute a controlled landing or to deploy some form of emergency recovery system that brought the aircraft down without destroying it. The burial trench in which the aircraft was discovered lies approximately 14 miles northwest of the main runway at Groom Lake, a distance consistent with a deadstick glide from 70,000 feet, if the pilot maintained optimal L/D ratio during the descent. The absence of impact damage to the airframe supports the theory of a controlled landing, possibly on the dry lakebed itself, followed by a decision at the highest levels of military intelligence to bury the aircraft, rather than risk its discovery through conventional salvage operations. The rationale for such a decision becomes clearer when analysts examine the final pages of the documents recovered from the cockpit. These pages contain technical specifications for the ramjet augmentation system, including detailed schematics of the fuel injection manifolds, combustion chamber geometry, and thermal management systems. The design incorporates principles of supersonic combustion that would not be publicly acknowledged until the development of scramjet technology in the 1990s, suggesting that Project Isinglass achieved breakthroughs in hypersonic propulsion that remained classified for more than 3 decades. The existence of such technology in 1964 implies that the United States possessed capabilities far beyond what was admitted to Congress, the public, or even allied nations during the height of the Cold War. The question of what to do with this information divides the intelligence community. One faction argues for full disclosure, reasoning that the historical significance of the discovery outweighs any remaining security concerns, given that the technologies involved are now widely understood and replicated by multiple nations. Another faction insists on continued classification, pointing out that acknowledging the existence of Project Isinglass would require explanations about why hypersonic research was abandoned after 1964 and why subsequent programs like the National Aerospace Plane Initiative of the 1980s appeared to start from first principles rather than building on the Isinglass Foundation. The resolution comes in the form of a presidential finding, a classified directive that orders the aircraft to be transferred to the custody of the National Reconnaissance Office and stored in a secure facility at Wright-Patterson Air Force Base in Ohio, where it joins dozens of other experimental aircraft that exist in bureaucratic limbo, too sensitive to display publicly, but too significant to destroy. The Smithsonian team is thanked for their contributions and reminded of their non-disclosure obligations. The civilian contractors who discovered the aircraft receive financial compensation equivalent to 3 years' salary in exchange for signing revised security agreements that prohibit them from discussing the recovery operation for the remainder of their lives. The excavation site is refilled with clean sand, and a new layer of contaminated topsoil is spread across the surface to discourage future investigation. Sound of helicopter rotors approaching from the south. But the story does not end with the bureaucratic burial of evidence. 3 months after the aircraft is relocated to Wright-Patterson, a convoy of unmarked vehicles arrives at the excavation site in the middle of the night. The convoy consists of 6 all-terrain trucks equipped with ground-penetrating radar arrays and a mobile drilling rig capable of extracting core samples from depths exceeding 200 feet. The crew works for 72 hours straight, systematically scanning the entire contaminated zone and extracting samples at 30-foot intervals across a grid pattern covering 2 square miles. What they are searching for remains unknown to the security personnel who observe the operation from the perimeter, but the intensity of the effort suggests that the buried aircraft was not the only artifact concealed in this particular section of the Nevada desert. On the 4th day, the drilling crew locates an anomaly at a depth of 137 feet. A metallic structure that radar imaging suggests is cylindrical in shape, with a diameter of approximately 8 feet and a length that extends beyond the detection range of the equipment. The crew begins excavation procedures, erecting another containment structure and deploying vacuum systems identical to those used in the aircraft recovery. But before the object can be fully exposed, the operation is abruptly terminated. Black helicopters arrive without radio contact or identification transponders, and men in unmarked tactical gear order the civilian crew to abandon the site immediately, leaving all equipment in place. The helicopters belong to a unit that does not officially exist within the organizational structure of any branch of the United States military, and the men who terminate the excavation carry weapons that are not listed in any standard military inventory. 4 seconds of absolute silence, subsonic rumble in the distance. The excavation site is sealed with quick-setting concrete to a depth of 50 feet, and the surface is covered with crushed limestone aggregate that is then compacted using vibratory rollers weighing 15 tons. Within a week, the entire area is regraded to match the surrounding terrain profile, and vegetation endemic to the Mojave Desert is transplanted across the site to accelerate the natural camouflage process. Satellite imagery captured by commercial providers shows no indication that any excavation occurred, and the restricted airspace designation that had been temporarily expanded to cover the recovery operation is quietly reduced back to its pre-excavation boundaries. The official record contains no mention of the second anomaly, no documentation of the aborted excavation, and no explanation for why an object buried twice as deep as the aircraft required such extraordinary measures to keep it concealed. Those who witnessed the termination of the operation are reassigned to different programs in different locations, ensuring that no single individual possesses enough contextual information to reconstruct the full scope of what was discovered beneath the sand of Groom Lake. The civilian contractors are subjected to additional debriefings conducted by personnel who identify themselves only with alphanumeric codes, and the financial compensation offered for their continued silence is increased to amounts that make refusal impractical. Sound of wind erasing tracks across desert sand. Years later, when a researcher using the Freedom of Information Act requests documents related to experimental aircraft programs conducted at Groom Lake during the 1960s, the response consists of 17,000 pages, with virtually every substantive detail redacted under exemptions, citing national security and ongoing intelligence operations. Buried within those pages is a single-sentence fragment that escaped the censor's attention. Project Isinglass secondary asset remains viable pending technological maturation timeline. The phrase secondary asset appears nowhere else in the declassified materials, and the meaning of technological maturation timeline is left entirely ambiguous. Intelligence analysts who specialize in parsing the language of classified documents suggest that this fragment refers not to the aircraft itself, but to something discovered during the aircraft's burial or recovery, something that the intelligence community judged to be beyond the technological comprehension of 1964, and possibly beyond the comprehension of the era in which it was rediscovered. The concept of a secondary asset implies the existence of a primary asset, and if the X-27A aircraft represents the primary asset, then the secondary asset must be something of even greater significance. Something that remains buried beneath 137 feet of Nevada hardpan and concrete, waiting for a future generation to possess the scientific knowledge and engineering capability necessary to retrieve it and understand its purpose. Sound of radio static punctuated by encoded transmissions. The aircraft itself rests in climate-controlled darkness at Wright-Patterson, monitored by sensors that track temperature, humidity, and structural integrity with milligram precision. It is inspected once every 6 months by a team of 2 engineers who are flown to the facility under false names and escorted by armed security personnel throughout their visit. The engineers document any changes in the aircraft's condition, photograph the airframe from standardized angles, and collect dust samples from the interior surfaces for chemical analysis. Their reports are filed in a database accessible only through a computer terminal located in a windowless room in the basement of a nondescript office building in suburban Virginia, and the data is reviewed quarterly by a panel of 4 individuals whose identities are known to exactly 17 people within the entire federal government. This is how the United States manages its most sensitive technological secrets, not through dramatic acts of concealment, but through bureaucratic compartmentalization so complete that even those who know fragments of the truth lack the clearances necessary to see the larger picture. The aircraft waits in darkness, a testament to capabilities that were explored and then deliberately abandoned. And beneath the Nevada desert something else waits, something that was judged too dangerous or too incomprehensible to bring into the light of day.